Welcome back to Statistics. In dealing with the normal distribution, there's some pretty commonly used notation that really shortens things, makes the problems less wordy, and it's used pretty widely across textbooks and also across software platforms. So I wanted to show you those real quick. Let's take a look. So the first idea we've already seen, actually, the n mu comma sigma notation for the normal distribution with mean mu and standard deviation sigma. And there you see the plot. And as usual, we're going to put the tick marks at spacings of 1 standard deviation. Speaking of standard, there's the notion of a standard normal distribution. This is simply a special case in which the mean mu is 0 and the standard deviation sigma is 1. So when you have those special values, you call it the standard normal distribution. And there you see its plot. There's a special notation as well for variables, statistical variables that have a normal distribution. And there you see it in blue. X is distributed normally with mean mu and standard deviation sigma is just represented by that x squiggle in mu comma sigma symbol. So for example, if you had a situation in which height is normally distributed among men in a certain population with a mean of 68 inches and a standard deviation of 2.5 inches, you could compress all that into that little equation I have below. X equals height in inches, and it's normally distributed with mean 68 and standard deviation 2.5. In talking about the proportions that are represented by areas under the curve from a normal distribution, there's also some special notation. So when I say the proportion of x values that are greater than b, I can denote that with a little symbol p x greater than b. And all that means is exactly that English sentence. You see the area highlighted down there, and that area it would be equal to the proportion of x values who are greater than b. That's called a right-tailed proportion. A left tail would mean the proportion of all x values that are less than some fixed value a. And so you see the symbol there, you just p x less than a, and it stands for that proportion. So it would be represented by the area under the curve to the left of a, and that's of course a left tail. It's also very common to calculate in-between proportions. So what proportion of x values lie in between a and b? Well, those would be x values that are both greater than a and less than b. And so you see the symbol there, p, a less than x less than b. And there it is in the graph, and that area would be equal to the proportion. Finally, it's pretty common to see a two-tailed kind of calculation in which you're looking for the proportion of values that are either less than a or bigger than b. And so we would represent that with the symbol p, x less than a, or x greater than b. And again, you see the graph and the area highlighted there. So those are some fairly common types of proportions to calculate, and our SALT tool works exactly the same way here. Here we're in the distribution calculator. You see we're calculating normal distributions right now. It comes up by default in the standard normal distribution, so a mean of 0, a standard deviation of 1, and you can type into either of these boxes to change the mean or standard deviation to whatever problem you're dealing with. These buttons over here we've also seen, and they distinguish between those four types: left tail, right tail, both tails, and in between. So to do a problem, you would simply choose, recognize first of all what kind of problem you have. If I've got for instance, a in-between problem in which I'm trying to find the proportion of, say, a standard normal distribution that lies between -1 and 2, I would just use the tool that way, and you read off the proportion right down here, and that turns out to be about 81.9%. So 81.9% of a standard normal distribution lies between -1 and 2. And the other kind of problems would work the same way. You could do a both tails problem here, and again, you would just use the boxes here to adjust the values. So the left-hand box works for the left tail. Maybe I want to look at things that are less than -1 or greater than 2, and I would read the answer off in the box below. Notice right here that SALT is actually using that same notation we just talked about. Kind of, it's hard to see, it's in gray here, but it reads the proportion of x values that are less than or equal to here. Sometimes you'll see that, less than -1, or greater than or equal to 2. I should mention here that for normal distributions, in fact, for any continuous distribution, you don't really have to worry too much about less than versus less than or equal, because the proportions turn out to be the same. So usually I'll just use less than. If I use less than or equal to, don't freak out, because it'll be the same proportion as if I had used less than. But that's only true for continuous variables. For variables that aren't continuous, that may not be true, but it is for normal variables, and so we'll use that. Okay, quick little introduction to some of the tools and techniques and terminology for normal distributions. We will be back at you soon with some more info. In the meantime, take care.